Hi, geometry students. I really hope this video finds all of you well. I do miss all of my students, but I really do especially miss my geometry students. I've been working with you guys now for nearly 2 years. You're almost juniors, and it kind of breaks my heart to have to be teaching you remotely. But I think this is a real opportunity for us. So let's stay optimistic, and let's show the world that we can learn remotely. In today's video, we're going to learn how to use trigonometry to find the area of regular polygons. It's best to demonstrate it and not talk too much about steps and process. So let's just jump right over to a sample worksheet that's going to look just like your mastery and practice assessments on CUDA. Okay, so these first two figures are pretty easy. First, we have to find the area of this triangle. Okay, now notice that we have a problem, and that is that we have one side length, but we don't have the height. Normally, we would do base times height divided by 2, but we don't have the height. So what do? See, we're missing this piece here. What is that? So let's think about this for a minute. We have a triangle. The triangle angle sum theorem tells us that the total internal angles of a triangle have to add up to 180 degrees. So that means that this angle plus this angle plus this angle has to equal 180. Well, okay, so we have 180 total degrees. So we'll divide that by 3 to find out that each internal angle is 60 degrees. I think that should be fairly easy to grasp. So we can label those angles. Let's use orange. So this is 60 degrees. This is 60 degrees. This is 60 degrees. Now imagine if you can that we split this triangle in half. Just like that. Okay? So now you have two identical triangles that are just mirrored. There's a 90-degree angle right here. And so each of these little side lengths is now 2.5. 2.5 and 2.5. So this is a bit of a different situation because now this angle changed up here. It's not 60 degrees anymore. It's two angles that are each 30 degrees in length. So this angle right here is 30 degrees. And this angle right here is 30 degrees. Okay, so think about it like this. You have two smaller triangles that each look like this shaded triangle here. And so what we need to do is find the area of one of these small triangles and then just multiply it by 2. Okay? So let's do that. We're going to use trigonometry to do that. Let me redraw one of these triangles just as a sketch. So down here I've got, let me try to mimic the exact angle. Down here I've got this little triangle here. Okay. It has a side length of 2.5. This angle is 60. And this angle is 30. how can we use trigonometry to find the length of this missing side right here? This is what we need. Remember, this is the height. So we could think about it this way. If we're looking at this side from this angle, okay, if this is our eyeball over here looking this way, we could say that the sine of 30 multiplied by the radius is equal to 2.5. Well, unfortunately, we don't have the radius. So let's look at this angle over here. Let's look at it from this perspective. So notice now I've got something I can work with. I have the opposite side, which is what I want, and I have the adjacent side. So going over our little saying, so ka toa, I can use this one, tangent, to solve for this height right here. This is how that looks. Tangent, or tan, of 60 degrees is equal to something which we don't know, that's the opposite side, over the adjacent side, which is 2.5. Okay, so in order to find that opposite side, I just multiply both sides by 2.5. And I find out that my missing side, or my height, is 2.5 multiplied by the tangent function for 60 degrees. So we're going to have to use a calculator to do that. Your phones actually have this calculator. If you pull up your calculator and then you put your phone in landscape mode, you can get the tangent of 60 degrees. But I'll pull up the graphic calculator here and multiply 2.5 times the tangent of 60 degrees. Now I want to make sure of something first. I want to make sure that my calculator is in degree mode. Okay, it's in degree mode. The default setting is for it to be in radian mode, but it's already in degree mode. So we're ready to compute this. And it tells us that the answer is 4.330127.019. Okay. So we'll just use the 4.33 part of that. So it's approximately equal to 4.33. Well, at this point, we now have this height, okay? Let me clear some of this stuff out so we can... So now we know that this height right here is 4.33. So I can actually use now base times height divided by 2 in order to find the area of each of these little triangles. I could do 2.5 times 4.33 divided by 2. And then I could multiply that by 2 to get the area of this whole triangle. Okay, so this is the area of this, of half of this triangle here. 2.5 times 4.33. So we'll do base times height divided by 2. So that would look like this. 2.5 times 4.33 divided by 2. Okay, so let's go back to the calculator to help us out with that. 2.5 times 4.33 is 10.825 divided by 2 is 5.41. That's the area of half of the triangle. So what we need to do is multiply that by 2 to get the area of the big triangle, of both triangles together. So that gives us a total area of approximately 10.825. Okay. So the smaller area was 5.4. All right. That's this smaller triangle area. If you multiply that by 2, you get 10.8. These are approximate values, but that gives us the answer choice D. Okay? So that's kind of how you're going to do these problems. The next one is easy. You're trying to find the area of a square. So it's just 3 squared, right? 3 times 3. Is that how that works? So if that's the case, 3 times 3 is 9. The squares are easy. Moving on. So here's where the stuff gets more interesting. Kind of the big key here is, how do you divide this shape, which is a 6-sided shape? 1, 2, 3, 4, 5, 6. This is a hexagon. How do you divide this shape into smaller triangles? Well, I connect opposite sides like this. Okay, so now we've got this big triangle, and all what we've really done here is we've broken it down into 1, 2, 3, 4, 5, 6 smaller triangles, and the process for solving them is going to be identical to this process that we just did with this one triangle here. So let's go through the process. Now, the question is, what is this angle? Okay. Well, here's the answer. You take the total number of sides, in this case 6, and what you're going to do is divide that out of 360. Okay, because this, if you were to keep going around, would form a circle. That circle would add up to 360 degrees. So in order to find one of these little internal angles, you take 360 degrees and you divide by 6. Okay, so 360 divided by 6 tells me that each of the internal angles of the triangle is 360 divided by 6, 60. Okay, so let me zoom in on this a little bit. Oops. So now we know that this is 60 degrees. So think about it this way. You don't have a hexagon that you're trying to solve the area for. You have a triangle that looks like this, and you're going to multiply whatever area you get by 6. Okay, so this has 60 degrees. And this is 5 meters, okay? Well, we're going to play the same game we've been playing all along. We're going to divide the triangle in half. And now we don't have a 60-degree angle here. We have a 30-degree angle. Okay, so this has to be 60, and this is a right angle. So we've already solved this, haven't we? we know that if this is 5 meters all the way across, then this little piece right here, this side length here, is 2.5 meters. Well, those are the exact dimensions of this triangle here. Okay, so we already know that the total area of a triangle whose side length is 5 is 10.8. So what you would have done is you would have said, okay, 2.5 times the tangent of 60 degrees is equal to 4.33. And then you do 2.5 times 4.33 divided by 2. .33 is the height. Okay, so then it's 2.5 times 4.33 divided by 2. Okay, and remember, let's go back up here and take a look. That was equal to 5.4. .4 times 2 equals 10.8. So that's the total area of this one triangle here is 10.8. Okay, that's the area. Now, bring that back up into this picture. The area here is 10.8. And that means that all these other areas are 10.8. Just like that. So the total area of the triangle, of the hexagon, is 6 times 10.8, or thereabouts. Okay? Let's do that. 6 times 10.8. 64.8. Okay? The closest one to that, if you round, is 65. Okay, so now that we've got that one done, we can move on to the next shape. Okay, so the next shape is an octagon, like a stop sign. Let me just do a quick check in OBS to make sure the recording is still going. Good. Okay, so here in number 4, we have 1, 2, 3, 4, 5, 6, 7, 8 sides. That's an octagon. And we can split that into smaller triangles like so. So we're just connecting opposite sides or opposite vertices. See, I'm going to do this one. Okay, so now you just have 8 small triangles, and we need to find out what each of these angles are right here. So we just take 360 and divide by 8. Okay, so this might actually give us a fractional angle here. So 360 divided by 8 is, it's 45. Okay, so each of these is 45 degrees inside. So this is 45 degrees. All of these angles here are 45 degrees. Okay, so Well, remember our process. We're going to extract one of these triangles and just work on it, and then multiply the area of it by 8. We have another problem here, and that is that we weren't given the side length this time. We were given the total perimeter. So the total perimeter is 32. To find one of the missing side lengths, we would need to take 32 and divide by 8. Okay, so that's going to give us the side length. So let's go to our calculator here and do 32 divided by 8. 4. Okay. So now we can draw one of our triangles here. We have a side length of 4, and we have this angle is 45. Now we split the triangle in 2. Like this. And so this angle right here is going to be 45 divided by 2. Let's see what that's equal to. 22.5. Okay. So that means that this little angle right here is 22.5 degrees. Okay, so here's the situation we face. We got to figure out what this angle is now. All right, so we have another little shape here. Here's this little half triangle here. We divide the side length by 2, so this has a side length of 2. We don't know the height. We know that this angle is 22.5, and we need to find out this angle here. So to find this missing angle here, we do 180 minus 90 minus 22.5. Back to the calculator. 180, oops, minus 90 minus 22.5. 67.5. Okay, so that means that this angle right here is 67.5 degrees. So let's go through our process. We're looking this way. We want to use the TOA, tangent equals opposite over adjacent. So we'll say that the tangent of 67.5 degrees equals opposite over adjacent. So the unknown over 2. So we multiply both sides by 2. And we see that we'll find the height of this triangle here by multiplying 2 times the tangent of 67.5 degrees. And let's see what that is equal to approximately. 2 times tan of 67.5. Okay, approximately 4.828427. All right, I'm going to write a few of those numbers. 4.828427. 2.84. That's what I'll write. Okay, that's the height right here. Okay, so we've got the height now is about equal to 4.8284. So we can find the area of this little triangle by doing base times height divided by 2. So that would be 2, the base, times the height, 4.8284 divided by 2. Well, here's a cool trick. These cancel out. That won't always work. But that means that the area of this triangle is equal to approximately 4.8284 meters squared, or units squared. Okay, that was half of this triangle. Okay, that's that area there. So if we want the area of the full triangle, we just have to double it. So now what we're going to do is we're going to do 4.8284 times 2. Back to the calculator. 4.8284 times 2. 9.6568. Okay. I already forgot it. 6568. That is the area of this total triangle. And remember, there are 8 of these because it's an octagon. So here's what we know, 9.6568. This is 9.6568, and so are all of these. Okay, so all the areas are 9.6568. So if we just multiply 9.6568 times 8, we'll have the total area of the octagon. 9.6568 times 8 equals. This is going to be our answer. We have to round it. So let's just multiply that times 8. 77.2544. They said round to the nearest tenth, so 77.3. Let's see if one of our answers is close to 77.3. And there we go. Okay, so we would choose answer choice C because that's 77.3. Okay, so that's the process for these symmetric shapes here, the hexagon and the octagon. Well, now we have to take a look at these two shapes. Now, these look a little bit weird because they're not an even number of sides. Let's count up the sides on this one. 1, 2, 3, 4, 5. So this is a pentagon. It has 5 sides. And so what we have to do is split this into smaller triangles. Okay? So think for a minute. You can't just start connecting sides. You have to find a center and build your triangle that way. So think about that for just a minute. So I realized just for the past few minutes there was no audio. And so I want to make sure to go over this last number here, number 6, just to make sure that you guys understood what I was doing. This is a heptagon. This is a 7-sided shape. I split the heptagon into smaller triangles, and then I divided 360 by 7 to find that each of the angles of those triangles 51.43 degrees. So what you're going to do is just follow the process that you've been doing all along to solve for the area of one of the triangles, and then just multiply it by 7 to get the total area. And so what I'd like you to do is go ahead and give this a try in CUDA, watch this tutorial again, and then when we have our live instruction session, you can ask any questions that you have. That's currently scheduled for Wednesday at 11 a.m. So make sure that you're tuning in on Wednesday at 11 a.m. to the Zoom session so we can go over these problems. And I will be going over the practice problems at that time. In between now and then, if you have any questions, please reach out on Remind, and I'll be more than happy to help you out one-on-one or in small groups. So once again, guys, I really do miss you, and I really look forward to us getting back to some state of normalcy. But until then, that is the tutorial on how to find the area of a regular polygon. Thank you very much for watching.